Have you ever pondered on the puzzling question of how measurements might change when viewed by observers in different states of motion? This seemingly simple quandary has been the genesis of some of the most groundbreaking theories in physics. Our tale begins with a young Albert Einstein in the early 20th century. Einstein, a patent clerk in Switzerland at the time, found himself questioning the established norms of Newtonian physics. He was particularly intrigued by an age-old assumption that all observers in the universe, irrespective of their location or state of motion, would perceive identical measurements of space and time intervals. Einstein, however, had a different idea. He proposed that all measurements are, in fact, dependent on the relative motions of the observer and the observed. This revolutionary concept laid the foundation of what we now know as the theories of relativity. The first of these, the special theory of relativity, came to life in 1905. It emerged from Einstein's acceptance of an unusual yet fundamental fact, that the speed of light remains the same in all reference frames, regardless of their relative motion. This theory primarily deals with non-accelerating reference frames and is intimately tied to electric and magnetic phenomena and their propagation in space and time. Fast forward to 1916, and we find Einstein grappling with another complex phenomenon: gravitation. He realized that his special theory of relativity was not equipped to deal with accelerating reference frames, a condition that is crucial when considering gravitational forces. Thus was born the general theory of relativity, a theory that forever changed our understanding of gravity. Both these theories, the special and the general theory of relativity, stand as towering milestones in the history of modern physics. They have altered our perception of the universe, leading us to question and explore the very fabric of reality. In summary, the theories of relativity challenge the classical physics notion of absolute measurements of space and time. They propose that all measurements are dependent on the relative motion of the observer and the observed. The special theory of relativity deals with non-accelerating frames and is closely linked to electric and magnetic phenomena. On the other hand, the general theory of relativity delves into the realm of gravitation and accelerating reference frames. Both these theories, proposed by Albert Einstein, have significantly shaped our understanding of the universe and continue to inspire physicists around the globe. So the next time you find yourself observing the world around you, remember that your measurements might just be a little different from those of a passerby on a speeding train or a distant observer on a far-off planet. Such is the fascinating world revealed by the theories of relativity.